It's summer, here in the Arctic. The Arctic tundra is teeming with wildlife and abundant vegetation that helps support the fragile ecosystem. 1,200 kilometers from the North Pole, Ny-Ålesund is the northernmost settlement in the world. Once an active coal mining hub, today it is a buzzing science village. The Arctic is warming faster than any other part of the world, and the evidences are now easily getting noticed here.
I'm very impressed by the changes. It's every year, since 2006, really climate change is happening here very much. Until 2006, the people here could cross the fjord in winter to the other side. Every winter there was enough ice to walk over the ice. Since 2006 it hasn't happened anymore. So that's just, and it means that when the fjord is covered with ice, then the warm water can't go to the atmosphere. But when there's no ice, all the warm water goes to the atmosphere, the heat goes to the atmosphere, and also water vapor goes to the atmosphere. And that makes Arctic amplification, that makes it more temperature increase in the Arctic than everywhere else.
The Arctic sea ice cover has declined over 30% in the recent years. This rapid ice melt has drawn the attention of the entire world, including Indian scientists. As of 2008, Indian scientists have been actively involved in studying the Arctic region by establishing a permanent research station, Himadri. The scientists here have been trying to understand the complex processes and the hydrological changes in these Arctic fjords and the surrounding environment by implementing several long-term monitoring programs. What happens in the Arctic doesn't stay in the Arctic. A recent study does indicate a strong teleconnection between the Arctic and the Indian monsoon. The rapid melting and retreating glaciers have been raising concerns about our future. These are not isolated phenomena that are seen only in the Arctic, but similar effects are being observed in one of the high-altitude cryospheric regions on the Earth, the Himalayas. The majestic land of tall mountains and glaciers is currently one of the world's most sensitive hotspots to global climate change. A new report suggests that at least a third of the Himalayan glaciers are expected to melt by the end of this century. A situation that is predicted to intensify in the coming years, with dire and far-reaching consequences on availability of water, food, and energy. All the major North Indian rivers owe their origin to thousands of glaciers in the Himalayan region. Nearly 1.5 billion population depend directly on these rivers. According to the latest glacier inventory, there are about 9,575 glaciers in the Indian Himalayan region. With changing climate, there are empirical evidences of how the melting of these glaciers are affecting both regional as well as global climate. A team of scientists are now braving the odds to carry out research in these extreme conditions and jagged terrain to understand the impact of changing climate on these glaciers. This team is currently monitoring 6 benchmark glaciers in the Lahaul and Spiti region. Today, they are planning to investigate the Sutri-Dhaka Glacier.
We are heading to Sutri-Dhaka Glacier. It is around 25 square kilometers in area and 11 kilometers in length, and it is our benchmark glaciers. We are studying that glaciers very thoroughly. So we are starting our scientific activities first from Sutri-Dhaka Glacier. So we are taking scientific equipments like flow tracker and then differential GPS, coder and other equipments, and we'll be starting our scientific activities from tomorrow. So we'll be pitching an advanced camp today, and from tomorrow we'll start our activities.
The team, along with the porters who have been camping at the high-altitude research station Himalayas, will initially need to climb to an altitude of around 4,500 meters through a highly menacing terrain. On reaching the snout, they will then have to trek another 6 kilometers on the glacial ice, covered with dust and debris, to reach the advanced camp. The team's primary objective is to undertake the glacial mass balance studies. Over the years, they have installed a network of bamboo stakes throughout this glacier.
We drill deep down to 10 to 12 meter, and we install the stakes depend on the melting rate of this location. So this location, the almost melting rate is 5 to 6 meter per annum. So we try to install the stakes almost 10 to 12 meter, because at least one time installation will continue for 2 years.
Every year, they observe the glacier melting by measuring the exposed stakes. The next day, the team prepares to head to an altitude of 5,200 meters in the accumulation zone. Adhering to all the safety protocols, they carefully navigate through the crevasse zones. Here, the team digs a pit to measure the depth and density of snow, giving them an estimate of snow accumulation over the last season. This data, along with the stake measurement in the ablation zone, are used to calculate the mass balance of this glacier. Over the last couple of years, the team has seen a negative trend among all benchmark glaciers, indicating the effects of changing climate. At the front line of climate change are the oceans that are getting impacted by increasing carbon dioxide levels. Here, at 65 degrees south latitude in the Southern Ocean, close to the Antarctic coast, the captain of the expedition vessel, S.A. Agulhas, carefully navigates through these ice-clogged waters, knowing others have attempted and failed. Southern Ocean has an immense influence on the Earth's climatic system. This ocean encompasses the Antarctic continent and connects the Atlantic, Pacific, and Indian Oceans. It stores and transports more heat and carbon dioxide than any other latitudinal band on Earth. Large amounts of carbon dioxide is locked away in the cold bottom waters of the ocean than in the atmosphere. Extreme conditions make it one of the worst places to conduct any scientific studies. Now, an Indian scientific expedition is attempting to unravel the mysteries of this ocean. Over the next few weeks, the team will stop at several multidisciplinary locations. Here, the team will operate several instruments that would collect scientific data, water, and biological samples from different depths, and also monitor several atmospheric parameters. During the last several decades, this part of the ocean is witnessing some drastic consequences due to the increase in ocean acidification. Scientists are also noticing a warming trend in these deep waters that store large amounts of carbon by acting as a carbon sink. Another source of carbon storage that is rapidly getting affected by the increase in global temperatures are the Arctic permafrost. The degrading permafrost in the Arctic region could pump billions of additional tons of methane and carbon dioxide into the atmosphere every year. A threat that has yet to be fully accounted for in climate models.
Permafrost is any land that remains 0 degrees Celsius or less continuously for 2 years or more. And so this is a typical landform that is available in cold climate, mostly available in the northern hemisphere, but there are some permafrost starting to come out or being discovered in the southern hemisphere as well, some available in Antarctic.
Here, in Neolazin, scientists are noticing patterns of rapid thawing of these permafrost regions. In order to reach the study area, precautions are taken by mandatorily carrying a rifle while leaving the settlement, as a preventative measure against any encounter with polar bears. Scientists are discovering destabilized landscapes where permafrost that once thawed a few inches a year can now abruptly thaw up to several feet within days or weeks, and thereby accelerating emissions of up to 1,600 gigatons of carbon that is still locked underground. Thawing permafrost also has a huge impact on natural ecosystems, economy, landscapes, and also on growing infrastructures.
This is actually a very good example of what permafrost thawing or rapid thawing can do to infrastructure. This is an old, I believe, water pipeline, or might be, I think it's a water pipeline. So they're sitting on top of some poles, and so over the years, what happened? The permafrost underneath it thawed, and actually thawed a lot more than expected. And this whole, like the line, it just tilted to the side.
The threat to landscape and infrastructure due to climate change are also evident in the Himalayas. The team is monitoring a proglacial lake created by retreating Gapong Gat Glacier. Situated at an elevation of around 4,000 meters, this proglacial lake is a potential candidate for a glacial lake outburst flow event. Over the last 4 decades, the studies have indicated that the volume of the lake has increased by over 20 times. Proper monitoring and management of such glacial lakes across the Himalayas are now essential to prevent calamities, considering its close proximity to civilization downstream. Understanding the impact of climate change in the Himalayas isn't just challenging, but also extremely difficult, owing to these highly undulating and unforgiving terrains and abruptly changing weather phenomena. During a regular monitoring visit to Bara Shigri Glacier, the team gets trapped in an intense snowstorm and loses contact with the base camp. "5 days of battling the extreme weather and snowfall, team finally manages to return to a safe place from where they were evacuated. After carrying out majority of scientific operations in the Antarctic waters, the team has now started the return leg. Sighting of icebergs has now reduced, and the water is no longer calm. As the research vessel heads back, the captain gets updates of an approaching cyclonic storm. While he charts a course to avoid the storm, the weather packs in. The team is put on high alert and is advised to stay indoors. All scientific operations are now put on hold. After almost 2 days of intense rolling and pitching, the storm has now subsided. Storms like these only further explain the extreme difficulties and challenges of conducting any scientific studies in these waters. A clever way of carrying our observation in these waters is by deploying a specialized float known as ARGO. ARGO, or Array for Real-Time Geostrophic Oceanography, is an international program that uses profiling floats to observe temperature, salinity, currents, and bio-optical properties in the oceans around the world through the years.
So we're going to deploy a biogeochemical float, which is part of the SOCOM project, the Southern Ocean Climate and Carbon Observations and Modeling Project. So this is like an ARGO float. It's equipped with a CTD sensor and an antenna to send the data via satellite. And then it has also some biochemical sensors like the fluorometer and backscatter, nitrate, and oxygen and pH. So like a normal float, it will descend to 1,000 meters and it will drift at 1,000 meters for 10 days. After which it will descend to 2,000 meters and then it will profile up to the surface, sending then data via the antenna on the top. And then it will repeat the cycle.
These floats have played a vital role in increasing our understanding of the ocean, as the data from these floats have helped the scientists comprehend the seasonal changes. Our world is changing, and we are on the brink of climate crisis. Scientists today are using the latest technology and braving some of the harshest conditions on this planet to investigate these effects of changing climate. To watch few among billions take it upon themselves to face these odds, the greatest of odds in the coming times. Do we act, or do we sit back and let the inevitable unfold? This is the Climate Challenge.